Okay, can you see my screen, guys?
Yes.
Yes.
طيب, بسم الله الرحمن الرحيم. Last time what we did, okay, we looked at the different types of constraint that can be found on a binary relationship types, okay, and we said that we do have two types of constraint. The first one, which is related to the cardinality ratio, okay, for a binary relationship, where we specify the maximum number of relationship instances. We talk about instances that an entity can participate, okay, and we looked at our AR model. Okay, these are the participation instance or cardinality ratio of an entity which can participate within a relationship. Okay, and we went through every cardinality ratio. We said we can have 1-to-1 cardinality ratio, we can have 1-to-n, we can have m-to-n, or 1-to-n. Okay, so these are the type of the cardinality ratio that you have to specify within an ER diagram. Okay, and you should be able to define those type of cardinality ratio. And we said also we do have another constraint that can be applied to a relationship, which is with regard to the participation. Okay, with regard to the participation, we said we do have something that is related to the existence of the we said that we do have the participation which is based on how, let's say, an entity or is related to another entity, whether it should be related directly, or we can have, or an element can not participate in such a relationship. Okay, and we looked also, okay, we said we do have a full participation where we do have two double line, and we can have a partial participation. Full participation means that every entity element inside that entity employee should participate in the relationship that is related to, which is, for instance, in our example here, we do have works for. And every department should be related to the works for relationship, which means, that means every department in element in this department entity should have an employee. And the same thing for the partial. We said the employee, we do have here partial participation. That means not necessarily every employee should participate in managers. As by logic in the business, not everyone is a supervisor or is a manager. We can find employees or element of the employee entity who are not manager. Okay, so this is with regard to the participation of the constraint for the participation of a relationship. Another type, we do have another thing that is we mentioned yesterday, and we started by defining it, which is this double line diamond shape. Do you remember what we said about it, Shabab?
That it is a weak entity.
It is a weak entity. What is meant by weak entity?
It cannot exist without employee.
Naam?
It cannot exist without a strong entity.
Yes, it cannot exist on its own. We said that we do have within our diagram or within our AR diagram, like this one, we do have an entity dependent of, this is the relationship. This is the entity dependent, which is a weak entity. Okay, and even if it does have its own attribute, okay, or key attribute, but we said that this dependent weak entity cannot exist within or without the other entity which is related to, which is the strong. Okay, in, let's say here we do have a weak, and this one is a strong entity type. Okay, and we said that this weak entity, okay, or that is identified by that specific relationship dependent of, okay, it is related to another entity which is the employee through some attribute values. Okay, can anyone guess what will be the attribute value that we can link this dependent weak entity with the strong employee entity? Or let me say it in another, rephrase it. Can we have in the company database, can we have two dependent who have the same name, sex, birth date, and relationship?
Yes.
Yes, that's no problem. But we cannot have two people who have the same ID, for example.
Okay, we don't have here any ID. Okay, we don't have a name. We can have two employees who have two children, like two boys, for instance. They do have the same name, same sex, same birth date, and same relation. They are both son of those two different employees. Now, how can we differentiate between one dependent and another dependent who have the same, all the attribute value, they are the same? How we can differentiate them?
By relate them with
The employee.
employee.
Good. So we need to relate them to the employee. And what will be, let's say, the candidate here, the attribute that will be selected to link the dependent with the employee? Can we have a name? Can we link this dependent with this employee by the name?
No.
Why no?
Because you would have the same name of two different
Yes,
employees.
we can have two employees having the same name. That means we cannot differentiate. If we put the same thing, if we do that, that means we cannot differentiate between dependent or employee Ahmed or Omar with another employee Omar, having two same dependent name, sex, birth date, and relationship. So we need to think about something that is different. Which one?
By the key.
Now?
By the key.
Barakallahu fiik. By the key. What is the key here for the employee?
SSN.
SSN. So that means when we link this dependent, which is the weak entity, we will link it to the employee, or to the parent, or to the strong entity. We call it owner entity. We call this one as the owner. Why? Because that employee owns the dependent. Because that dependent cannot exist without the owner or the employee. That means what we need here to add later, we're going to see later in another chapter when we do translation of this diagram into, let's say, into computer-based things. So we will add to the dependent, we will add that SSN, and we will add it here. And what we will do, what do you think, Shabab, will be the key for this dependent? When we add this SSN, employee SSN, we will add it here. What will be the key?
Foreign key.
The name.
Shabab, still name, the key. We said name cannot be the key.
It's going to be the relationship.
We need something that is different for every entity.
Will be
Relationship.
composition of two things.
Yeah,
Yes, go ahead. Yes, good idea. Yes.
SSN with
and
the name.
Barakallahu fiik. You can see here we have that partial, let's say temporarily name or the key for the dependent. It is dotted line. Then what we will add? We will add the SSN and the combination of SSN plus name will be considered as the key together. They will form our key that will differentiate one dependent from another. Let me now ask you another question. What if we didn't choose the name? I will choose only the SSN to be the key for this dependent. Is there any
No.
problem?
yes, because there
Yes, that is the
are
problem.
children. They're all gonna have the same thing of one employee.
Yes. So we cannot differentiate for one employee. For instance, if an employee has 5 children, okay, we cannot differentiate between them. Okay, specifically, if we say that those children might have the same name. Okay, let's suppose that we do have the first name is the same for two kids, for instance, or two child. Okay, what we can do, that's why we have to link, we have to write the SSN and the name that should be chosen as the key for the dependent in order to differentiate between one dependent and another for the same employee. And of course, for differentiation of the dependent between employees, we can use only the SSN. But here, as we mentioned, we are working within the database where we do have everything is included. So we need to do some types of differentiation even between employees and even within the same employee.
But Doctor,
Yes.
SSN with name cannot be repeated.
Yes, you cannot have it is impossible. Even if you do have the name is the same, but the combination of the SSN and name will never be the same for two employees, will for two dependent. Because that SSN is different from one employee to another employee. So we will never have that combination SSN and name the same for two dependent or more than two dependent. The combination, now I'm talking about the combination, Shabab.
Doctor?
No.
So here in this case, it's going to be possible for one employee to have the exact same dependent twice.
Say it again.
For one employee, it would be possible for him to have the same dependent twice.
How? How come?
Isn't it
Unless they
possible?
are twin, if they are twin, توأم, with the same name, yes. even that, if you go to the birth date,
Okay.
if you go to the precision, maybe the timing of the birth of those twins, it will be different.
But is it going to be a problem in the database?
No, we said normally it's not possible to have this situation. A dependent, an employee who has two dependent with the same name, same sex, same birth date, and relationship. Usually, we cannot have that one. I said unless those two, three boys, for instance, they are twins. That's where we do have the same birth date.
Would that be a problem?
In that case, we might add another extra information. But usually, it's very rare to have such a situation. If we do have such situation, we need to have something else to be added. Maybe in the birth date, we can add maybe the time of birth exactly.
Dr. Ahmed, I have a question.
Yes.
My question is, does this database design, does this ensure that there's a backup of this design somewhere? What if something gets imprinted on the wrong side? What if you swap, say, employee and supervision, or somehow there's an error and you change the managers and workforce for?
That's why what we said it is very important at the beginning to do your requirement properly and do it correctly. Okay. And what we said once the database is designed and once the database is implemented, normally it should be stable. It should not change frequently. Okay. This is the situation when you do your requirement, when you gather information and you prepare the requirements and you are sure that those are the correct requirements right now. That means once you are satisfied, you go to the next step, which is the implementation. Okay?
No,
and that design will be based on, that implementation will be based on this ER diagram. Now, if you are going to change something later, at least you have to change it again. And we said that this ER diagram is helping you to understand your design, not to miss anything within your requirement.
Okay. Thank you for the answer.
Is that okay? Did I answer your question?
Yes, sir. Thank you, Doctor.
Normally, as we mentioned, normally it is a stable design. Okay? But in some cases, you might change some policy, you might change some requirement. So you need to reflect those requirements inside the implementation of your database. Okay?
Thanks.
Okay.
Thanks.
And one thing, if you can see here, we do have what type of participation, Shabab? This one?
It's
Now?
It's full, doctor. Full
Yes,
participation.
it is a total participation. Why it is total participation? Why we didn't put one line here, one single line? Why it is double line? Why partial?
all dependent are depends of employee.
What is meant by that?
يعني they cannot be exist without the employee.
Barakallahu. We cannot have, if we didn't put here a full participation and we put only one line here like this, here for instance, okay? We cannot have any, as we mentioned, it is a weak entity. That means it cannot exist. We cannot have a dependent who doesn't belong to an employee. That's why it is a total participation. We should have every dependent that you put or you included in your database, that dependent should be linked to an employee. But in the other side, it's not necessarily. Why we do have here partial participation? Can anyone answer?
Yeah, an employee may not have children.
Yes, an employee, not necessarily all the employee or not all the employees have kids, for instance. That's why not necessarily every employee entities inside that employee entity should participate in this relationship dependent of. That means we said we must everyone unless just let's suppose that situation that, for instance, within your organization you recruit only employees who are married and they do have children. At that moment you should put double line here. But in general, in real life, this is the case. Okay, employee might have or might not have kids. Okay, and when you do have kids dependent inside your database, you should make sure that those dependent are linked to an employee. Okay, Shabab, can we have another scenario? A dependent may belongs to two employees.
Yes, doctor.
Which case?
If the employees, the father and mother are employees in this company.
The father and mother are employees of that organization. You will have that dependent will have, let's say, when we say that dependent, that means that name, sex, birthday relationship, okay, is the same for two different SSN, okay, where you do have a father and a mother working together, working with the same organization or company.
Doctor, in that case, it should not be the relation between employee and depends of one, right?
Say it again.
In that case, if we have father and mother, between employee and depends of the number should not be one.
Yes,
right?
good, very good. We should change that in that situation.
Can be two or just n.
No, and la. If you put n, that means we might have zero, صح ولا لا? Which is not the case. Here we said at most, maximum one.
Okay.
Okay, we cannot have n. If you put n, that means there is a case where n equals to zero, which is not true. We cannot have dependent who doesn't have who is not related to an employee. Here we can have, let's say, we can have, for instance, 1 to 2, for instance. Okay. You can accept between 1 and 2, for example. But as we said, these are, let's say, a special situation. Okay, they are not always the same, but this is general. Okay, these types of AR diagram reflects a general things that are within the mini world of any organization. Okay, so we mentioned, we specified the weak entities. And you should define, when you do have in any requirement, you can define the weak entities that you do have within based on the requirement you gather. Okay, here we do a refinement of the AR diagram. Okay, what we mean by refinement. If we go back to one of our slides, you will see this one. Okay, if you can see, let's pick up anyone. Let's pick up employee. What is here? What is the thing that is different in this diagram for the employee with the previous one that we have seen now in the AR model?
It's more detailed.
More detailed. What else? Just to have a look at those attributes.
Each one is alone, separate, Doctor.
Okay, it is alone. Just forget it is alone. Let's look at this one, employee. Look at the attributes. Can you see this?
So they make Doctor works in project and hours. And
We do have
department as attribute.
Department is an attribute. Supervisor is an attribute. Works on is a multi-valued attribute. Okay? And the same thing, if you go to dependent, we do have the relationship, something, an attribute called the relationship. And we do have here employee. If you go, for instance, to department, we do have here, where is the manager? We do have manager, okay, as attribute. That's why we say it is a preliminary design. It's like this is a draft. The first design you do, you will say that, yes, let's have the attribute, for instance, for the employee. And for each employee, I will put the department where this employee works, who is the supervisor of that employee, and how many projects that employee works on. And for each project, you do have project name, for instance, and the number of hours, and so on. But at the end, what you will do, you will turn and translate and change those attributes into relationship. That's this is what we did in our ER diagram. Okay, in our ER diagram, what we moved those type, okay, or attribute, they have been changed into relationship. Okay, that's why we said that we are refining our ER diagram. Okay, we are making that our ER diagram more robust, because you will see later in next inshallah chapters, you will see what is the benefit of having such a relationship, and not to include, okay, in one entity we include everything. Okay, when we said I do have employee entity, that means I should have only information about the employee itself, not about the details of the departments, for instance, location of the department and the project number, location of project. We should not have that, because we will have some problems later when we do some update, and we will find ourselves forced to do many updates, and we might miss some types of information not being updated, and so on. Okay, so we turned those attributes into relationship, whether it is one-to-one relationship. For instance, for the works for, we turned it, okay, into one-to-many. Okay, for that works on. Okay, where is the works for? For that employee. Okay, let me check. For the department, with regard to the department, okay, for the employee works for, we turned it into one-to-n relationship. Controls, we turned it into one-to-n relationship. Supervision into one-to-n relationship. Works on, the same thing, into n-to-n relationship. And dependent of, we turned it into one-to-n relationship. Okay, so basically, based on those, this is a new, or let's say, the last or the final draft for our ER diagram. Okay,
Dr. Rida.
Yes.
When we're designing this ER diagram, are we concerned with the speed of how the database would perform, like the runtime speed? We're not concerned.
No, this is just for the logical. We are not specifying in ER diagram anything that is related to the physical layer, the physical design.
Is the diagram?
It is only the logical design. This is logical design that will help you to implement the database as the structure of the database itself, not the structure of the files, how they are stored as in the physical layer.
Okay, thanks.
Okay. Yeah. So we mentioned these are the, let's say, the symbols or notation that you should use in your ER diagram. Okay. These are the different types of, you do have entity, weak entity, relationship, identifying relationship for the weak entity, the attribute, key attribute, multi-valued attribute, double lines, composite, that means you do have one attribute that is composed of other attributes like an address, derived attribute, like what we did last time, total participation, this is total participation, and you do have cardinality ratio, 1 to n. Okay, we're going to see now the other one. And another thing that I think I didn't mention, I don't know if you do have it here, for the relationship, Shabab, for the relationship, yes, for the relationship, if you can see here, this is the relationship. This is not an entity, works on. Managers, it is a relationship. It is not an entity, but they do have attributes. Okay, a relationship might have attribute like an entity. For instance, if you want to track the number of hours an employee has worked on a specific project, you will have to put the number of hours. When I do have, for instance, for the managers, I want to track the start date of that employee when he was assigned to be manager of a department. So we will have this type of attribute, which belongs to the managers. And this is the derived. You remember, Shabab, the derived attribute. We said number of employee. We are not tracking, we are not storing the number of employees inside the department as, let's say, for the database, but we can, for each department, we can list or calculate the number of employees working for that specific department. That's why we say it is a derived attribute. Clear, Shabab? For the attribute, we can have attributes for a relationship. There is no problem. As like we do have attribute for an entity, we can have attribute for relationship in case we need such information to track some types of data or some types of information we need to get it. Okay, Shabab?
Okay.
Okay. Now we move on to another notation. As we mentioned, this is an example of an ER diagram with some specific notation where we have specified 1 to n, 1 to 1, m to n, and 1 to 1, for instance, or 1 to n. So these are a notation. We might have a different types of another type of notation we can use in our ER diagram. I will go back later to this naming. Okay, we do have what is known as min-max notation. What we mean by min-max notation? This is another alternative notation for an ER diagram. Okay, for instance, when we talk about min-max notation, here we specify it's like the cardinality ratio. We said the cardinality ratio, which is 1 to n, 1 to n, m to n. Here we are having something that is more precise. What we mean by being more precise, that means we are specifying, okay, the type of relationship or participation of an entity on a relationship, okay, based on a pair of integer, which is min-max, with each participation of an entity type or an entity type in a relationship. Now, for that minimum might be 0, okay, to the maximum, whatever the maximum, or you can have a maximum. When you said max, that means something that is greater or equals to 1. Minimum, that means something that is greater or equals to 0. That means you have this type of max, and you need to specify it. If we go back to our, this is a notation where we are replacing those cardinality ratio 1 to 1, or 1 to n, or m to n with the min-max notation. If you can see here, Shabab, can you see this 1, 1? Here we do have 4n. Anyone can interpret this 1, 1, which is min-max?
So each
That means
employee
so
will
it's just one
mean
more or
the
less.
first one is the minimum, the second one is the maximum. If you go to the employee with relationship works for, we said an employee works for a minimum in one department. An employee works for maximum how many department an employee, what is the maximum of department the employee can work is one. Okay, and we go here, for instance, this is another notation for n. This is a mean and this is a max. We say how many employees works for the department, or what is the maximum required based on the requirement. This number 4 is based on the requirement. This is just an example. You might have different number. This is just for you as an example to say, for instance, okay, for this department, what is the maximum number, or sorry, the minimum number for a department, minimum number of employees who works for that department. We say min is number 4. That means this is the requirement by, let's say, by higher management. We cannot have department having less than 4 employees in that department. And what is the maximum? Yes, Shabab, what is the maximum number of employees? It is max. We don't specify, we didn't specify maximum. That's why we said max, this n should be greater than 1, greater or equal than 1. And this one should be greater or equal to 0, the min max. Okay, the notation min max. This should be greater or equal to 0, and this should be greater or equal to 1. That means you should have something from 0 to maximum. Okay, here, what about this one? Okay, this is the best one. Okay, employee, you do have manager, okay, managers, and 0, 1. Here, and you have here department. If you can hear, we have more precisely putting the name. Okay, manager, and this is department managed. So if you look from the, if you look at it from employee, minimum 0, maximum 1. So how can you interpret that one? For the manager's relationship,
we can have no manager, or at max one manager.
No, we didn't say that. We cannot say we cannot have manager. That's not true. We're talking about employee. Employee can be a manager. Okay, here
employee,
manager. Now,
employee can
Yes.
be a manager of one department at most. يعني max.
yeah, will mean
Cannot be manage any department.
that means minimum 0. That means not every employee can be a manager. We can have an employee who has, let's say, a value 0 for manager. That means he's not a manager. And if we do find someone who is a manager, maximum is 1. An employee can be a manager of only one department, no more. He cannot be a manager for 2 different departments. Okay, that means here for the employee, we can find an employee who is a manager for maximum of one department, as we can find an employee who is not a manager, who is a manager of 0 department. That means he is not a manager. And if you look at the other side, the department, and with the department managed by minimum 1, maximum 1, what is meant by that?
So it means that there's at least one department that is managed by a manager.
No, we don't say at least one department. We say شوفوا department managed by minimum. معناه a department can have minimum of manager is 1. معناه we cannot find the department without a manager. We should have at least, here we do have at least, at most. Okay, at least 1. معناه minimum we should have 1 manager for that department. We cannot have 0. If we put here 0, معناه we can find a department without any manager. Here we said minimum. The department should have minimum of 1 manager. And what is the maximum number of managers of that department? We said also 1. That means the department should have minimum of 1 and only 1. This is how we can interpret it. Clear, Shabab, for this one, for this notation, min max? The same way, let's go here, for instance, 0n, department, controls, project, controlling department. What we can have? 0n, that means the department, yes, minimum 0, maximum n.
So a department controls either no projects or multi-projects.
We can find a department without any controlled project. They have not been assigned to any project. They don't have 0, or they can have many projects, n number of projects. They are controlling n number. And if you go to the other side, controlled project, a project minimum 1, maximum 1, controlled department. We go in this direction. We say a project minimum. Any project, if you pick up any project here, that project is controlled by a minimum of 1 department and a maximum of 1 department. Okay, that means when you do have a project, we cannot have a project without any department that is controlling that project. We should have at least 1 department controlling that project. And a project can belong or can be controlled only by maximum by 1 department. We cannot have 2 departments controlling the same project. Okay, Shabab?
Doctor, I have a question.
Yes.
In the logic. So a department can control no projects, right?
Yes, that means he cannot. He might have a 0 project to be controlled.
But an employee has to be working for a department, and at least 1 employee works on a project. So if an employee works on a project and works for a department should at least control 1 project.
لا هي ما تنساوش شباب. The department here we do have many departments. Who told you that a department that we are talking about is let's say you do have, for instance, you do have management department, computer science department. Okay, computer science department has no project. And I do have here management department, and this employee works for the manager department. Okay, that means he will works on that project. Okay, Shabab?
Yeah, because
don't forget
there are departments
that these
that
are the
work on
entity.
projects.
Entity معناها like a set, مجموعة. And inside it, you do have many elements, many departments. Here we do have many employees. Here we do have many projects. So don't pick up only 1 case and you say this is, say it doesn't fit with the logic. We always have something that is, let's say, for the department, we might have 0 department or department that doesn't have any project. We can have other departments that have project, and we do have employee who works for those departments that have a project. Okay? Like we do have a requirement, business rules or business requirement. We cannot, an employee works only for instance, a department which is controlling some project, for instance. And if that employee works for that department, that means that employee should work for some specific project.
But doctor,
Now,
how employee can go in some department that does not control any project?
say it again.
And he works. I said how the employee can work to the department that does not have any project, and at the same time he works for some projects.
Anyone can answer, Shabab? Can you see here minimum, maximum, minimum, maximum?
Yes.
We said that last time. An employee can work on how many projects an employee can work on?
1.
Minimum 1. What is the maximum? This is maximum. صح ولا لا?
Yes.
Okay, and that not necessarily an employee. This employee can work on 2 different projects that belongs to different departments.
Okay, and he can be in department and work for other department projects.
Yeah. No, don't link the project with the department. We're talking about an employee works on a project. Here we do have 1 to n, minimum 1, maximum n.
Clear, Doctor, clear.
Okay. So this is basically, anyway, this is whatever you say, this is a requirement. This is an example of an ER diagram based on some specific requirement. Okay, you might have different requirement, different type. I can change your requirement, and you will see that ER diagram will change completely. This is just to show you, to explain to you how things works and how you can do a design. Okay, because we are not now, we don't have the full requirement and information about this specific ER diagram. What we have in our hand, it is based on this ER diagram. We can conclude. If I give you an ER diagram and I will tell you just extract the requirement, you will be able to extract the requirement from this ER diagram just by looking at the min max, the relation, the weak entity, and so on. Okay, Shabab?
Clear.
Okay, another types of, to finish, another type of diagram or notation, which is known as a UML diagram or UML methodology, which is used software basically in the software design. Okay, and it does have many type of diagram. It depends on the software design purpose. This is an example of a UML class diagram. Okay, in UML class diagram, you can have some types of information that is nearly the same thing in ER diagram, but with different types of notation. This is just for your information. We're not going to use UML diagram, just to know that there are other types of model where you can do the things that are related to the ER diagram. Like we did with ER diagram, you will create different types of relation. Okay, different type of entity. I do have the name of the entity, the attribute. Here we can have the derived, for instance, attribute. You can have link those entity in the class diagram with the line, like we did, like a relationship, and we put the name of a relationship. We put the cardinality, for instance, more than a maximum, min, max, and so on. This is the type of relationship or an ER diagram where you do have, for instance, the type of this notation, for instance, whole participation. That means everyone should do full participation. When you see this diamond shape, like here, we should have full participation and so on. This is just another notation that is used that for you to know that there are other types of notation where you can represent a binary, for instance, a relationship in another notation with another, like this one, UML class diagram. Okay, Shabab?